Hello, in this video we're going to be talking about numerical data types and arithmetic operators. If you're just joining us, we have a running example going, an app for an ice cream shop. If you want to follow along, make sure you have that code open. You can find it on the course website if you want to download and start from this point. Okay, so first let's talk about the integral data types. These are data types that store whole numbers, and there are several different options. They really just depend on how big of a number you need to store. They vary by memory space. For the purposes of this course, where we're just doing very simple programs, you can just always use the type int, int, and for any time you want to store a whole number. Okay. I have these slides as kind of a reference point for the floating point data types, float, double, and decimal. Again, because we're learning so much in this course, just a little shortcut, we're just going to be using pretty much the double data type anytime you have a decimal point. But just want you to be aware that there are other numerical floating point data types out there. The float keyword data type is a little funky because you use a number, or excuse me, you put a letter after the number to make it a float, double, or decimal, which can be confusing for beginners. Just keep this slide. You can come back and refer to it after this course is over. I'm not going to test you. This isn't going to be on a quiz, and we're not going to use it in any of our examples on how to use the float data type. Again, we're just going to keep it straightforward and use doubles in this course. Okay, so we've been talking about variables, and I mentioned constants in the last video, which is just like a single number or a literal string instead of a variable. You can actually declare a constant the same way you declare a variable, but using the keyword const. Okay. What this does is it basically creates a variable, but a variable that is not allowed to change at any point during the program. So let me jump to the code to show you an example of what I mean. Now in this video, I'm looking at my code using Notepad++. I wanted to do this because now that we're getting a lot of different things going on in our code, I wanted you to be able to see things more clearly. Notepad++ is nice because it uses color coding, so it's easier to look at the code. Right? All of the comments are in green. The keywords are in purple. The literal strings are in gray. Okay? Anything that is commented out is green. So this program works exactly the same as Notepad, except it's easier to look at. You can keep using Notepad. You can use Notepad++, and you'll see it's going to get a lot better on Monday when we start doing the next chapter, chapter 3, and we start working in Visual Studio. Visual Studio also does this color coding, so it'll be a lot easier to see what's going on in the code. All right, so in the last video, we declared and assigned variables. Okay, and the nice thing about variables is you can change the value of them. Okay, so our numscoops variable, we initialized it with a value of 3, but anytime later in the code, if we change our mind, we could just assign it something else. Okay, or if we want to change the price per scoop, okay, we initially assign that a value of 125. If we change our mind, then later we can put something else. That's the nice thing about a variable. It doesn't always have a constant value. You can change the value of a variable. Okay, I'm going to erase those. That was just for an example. Now, a named constant is basically like declaring a new variable, except that variable, you're never going to be able to change the value of it. So if we write const, so I'm going to create a constant for tax. So let's say we have a tax value that we don't want to ever change. Okay, a tax value would be of data type double. So I'm going to put the constant keyword and then the data type keyword. Now I'm going to think of a name. I'm just going to call it tax. and I'm going to assign it a value of 75 cents. This isn't a very realistic example, but let's just say for the purposes of this example that the value of this tax constant is 75 cents. Okay, now I've already messed up a little bit because the convention, it's not required, it's not a syntax rule, but the convention is when you have a constant, you name it with all caps. Now what this constant keyword does is it makes it so I'm not allowed to change the value of this. This isn't a variable anymore, it's a constant. So I can't come down here and say, oh, now I want tax to be something else random. That's not allowed. That's going to give me an error when I try and run the application. Okay, don't forget your semicolon at the end. So here we've got some variables initialized, and here we have a named constant initialized. Okay, now in C#, we can use arithmetic operators, and they use the symbols that you're used to. So if you want to add, subtract, multiply, or divide something, that is fairly straightforward. So let me jump back to my code once again. So we have a price per scoop and a number of scoops. So let's say that we want to actually calculate what the price is going to be. So just a note before we do that, generally you declare or initialize your variables at the top of your code, and then you process them somewhere in the middle of the code, and then you do your outputs, like here we're outputting to the command prompt a statement at the end. So it's just a tip to better organize your code. Declare things at the beginning, process them in the middle, do your outputs at the end. And C# processes things in the order that you write them, okay? So you can't like add together your variables before you declare those variables. So that's why you usually declare your variables at the beginning, because you can't do anything with them until after you've declared them and assigned values to them. Okay, so let's say we want to calculate a subtotal. So let's create a variable for that. And that's going to be a double because it's going to have a decimal point in it. Let's call it subtotal. And I want the value of that subtotal to be my price per scoop multiplied by number of scoops, semicolon. Okay, so you can use these arithmetic operators, arithmetic operators, using literal constant numbers, or you can use variables in place of numbers. Anywhere you can use a number, you can replace it with a variable, and vice versa. Okay? That's the wonderful thing about variables. Okay, so I could have done, you know, my price per scoop 125 times the number of scoops. Right? I can do a literal number multiplied by a variable. I could do a variable multiplied by a variable. Okay, it's all mix and match. All right, so here I've used the multiplication operator to assign a value to my subtotal variable. So now if I display to the console, if I do write line, your subtotal is, and then we use a placeholder, and then we'll replace that placeholder with our subtotal variable. Whoops. I always do that. You have to put your closing quotation mark at the end of your literal string before your comma, and then you put the variable that's replacing your placeholder, closing parenthesis, semicolon. All right, if you need to catch up, you can pause. I'm about to save and test my code. Save. Jump over to my developer command prompt. Okay. So now I'm going to compile my ice cream.cs code. And it's giving us a warning error because we've declared a variable, our named constant variable, tax, which we haven't used yet. That's okay. There are no other errors, so our program should have compiled correctly. Now we can run it. And it gives us our subtotal, which is $3.75. It used your code instructions to calculate that total, and then it displayed it out to the screen. And then we've still got our output that we wrote in our original code on the previous video. Okay, there is another operator that has it's more useful than you might think initially, but it's called the remainder operator or the modulus operator. And what that means is when you divide something that you can't evenly divide and you have a remainder left over, that is the answer. So if you do 45 modulus 2, or sometimes programmers just say mod, 45 mod 2, the result of that is 1, because 45 divided by 2 is 22 with a remainder of 1. So this is the remainder operator. Now, let me show you an example of where this might be useful. I'm actually going to I'm going to come back to the ice cream example in a minute, but I'm going to create a new example that will make more sense for this modulus operator. So I'm going to create a new program. I'm going to call it time. And I'm going to put my main method there. Okay. Now I'm going to initialize a variable, an integer variable called minutes. I'm going to call it total minutes. And I'm going to give it a value of something over 60. So let's say 100 minutes. Now, what I want this program to do is if I have a number of minutes over 60, I want this program to calculate and tell me how many hours and how many minutes left over. So I'm going to declare two other integer variables, hours and minutes, and I'm not going to initialize them. I'm not going to assign them an initial value. I'm just going to leave them empty for now. And then what I want this program to do is I want hours to be set to the value of total minutes divided by 60. Now what that's going to do, when you divide two integers and assign the result to an integer variable, integers cannot hold decimal places. So even though I have total minutes, which is currently assigned to 100 as 100 divided by 60, so what we're doing here is 100 divided by 60, which normally you would think would have a decimal place in it. But since we're doing an integer divided by an integer and assigning it to an integer, the result is going to be an integer. It's just going to cut off the decimal place. So let's save this and show you what's going to happen. Whoops. Okay, so here, I want to save this as a C# source file. Okay, so I'm going to name this time. And before I compile it, this code isn't going to actually do anything. Let's put in a write line method so that we can actually see the results. So system.console.writeLine. And I'm going to put a placeholder in there. Hours. Whoops. Bear with me. That's the nice thing here. You're seeing me live here and all my mistakes. Don't forget to put that inside of quotation marks. Okay. And then after the comma, what we want to replace that placeholder with is our hours variable. Okay. So this is a number. It's an integer variable that is going to appear right here. It's going to say how many hours. All right, if that's too quick, pause the video. I'm going to save and test my code. So I'm going to compile my time.cs C# file. Okay, again, we have a warning variable, or excuse me, a warning error because we haven't used the minutes variable. That's okay. No other errors, so it should have compiled correctly. Now let's test our application and see what happens. Okay, so it says 1 hours. So that means that the hours variable is assigned a value of 1 because it did that 100 divided by 60, which is 1 point something something something. But the hours variable is an integer variable. It can't hold decimal places. So it just cut off anything after the decimal, which is, in this case, what I wanted it to do. Because I want to determine how many whole hours and how many minutes there are in 100 minutes. Division by integer stored in integer cuts off decimals. I'll just leave that in the notes for you. Okay, now I will show you how to use the modulus operator. So here, our minutes variable, I'm going to assign the value of total minutes mod, whoops, the percentage sign, 60. So what that does is it divides total minutes, it takes total minutes dividing by 60, and then it gives you the remainder. Okay, so now in my write line method, I'm going to put however many hours and second placeholder, however many minutes. Okay. So placeholder 0 is going to be replaced by the hours variable, which currently holds the value of 1. And placeholder 1 is going to be replaced by the minutes variable, which currently holds the value of whatever the remainder of 100 divided by 60 is, which should be 40. Now, if we save and compile, and run our code, time.exe, 1 hour and 40 minutes. All right, let's move on. All right, so when you're using arithmetic, there's an operator precedence, which is the same as order of operations that we all learned when we were younger. So multiplication, division, and remainder always are done before addition and subtraction. And you can override with parentheses Otherwise, expressions are evaluated left to right. Okay. This is something that I'm going to be using a lot. You'll see a lot in programming, so it's important. These are shortcuts, but they're shortcuts that you need to know. Okay, so you have the add and assign operator, which basically combines adding something to itself. Now, I'll show you what I mean here. This will be easier to explain with an example. So if you have a plus equals, minus equals, multiplication equals, divide equals, or a modulus equals, these all follow a similar concept, which I will show you back in our ice cream code. So I'm going to go back to my ice cream file. Okay, so in this ice cream file, at the beginning, we assigned num scoops, or number of scoops, a value of 3. If we want to increase the number of scoops, there's several ways we can do it. Okay, so if we want to add one to the number of scoops, we can actually use the numbers, the variable on the right-hand side of the assignment operator. Okay, so what this line of code is saying is I want to assign a new value to my variable num scoops, and the value that I want to assign to that variable is what's on the right of the assignment operator, as always. So then C# says, okay, what is on the right-hand side of that assignment operator? Well, there is num scoops, so it's going to take the value that num scoops had before, which was 3, and it's going to add 1 to it. And then the result of this, of adding those together, it's going to assign to num scoops, okay? So as C# is going through this code, I'm on this line, I'm on this line, here we go. At this point, number of scoops is 3, number of scoops is 3, number of scoops is 3, number of scoops is 3. Up at this point, number of scoops, we're going to add 1 and reassign it. So now number of scoops is 4. So when we're at this point in the code, number of scoops is 4. So when we get down here, it's going to take the price per scoop and multiply it by 4, because at this point in time, or at this point in code, when C# reaches this statement, then the num scoops variable will be holding the value of 4. Let's save that and test it. So we're going to compile our ice cream.cs file. We still have a warning error, but no syntax errors, so this should run. We type ice cream.exe. Okay, your subtotal is 5. Customer asked for 4 scoops. Okay, now, now I'm going to demonstrate the add and assign operator. Okay. I'm going to put this line inside of a comment, and I'm going to do the exact same thing with a shortcut. This line of code does exactly the same thing as this line of code. So what the add and assign operator does is it says, okay, the num scoops variable, I'm going to add to itself whatever is on the right side of this operator. Okay, so what this operator means is I'm going to take whatever variable I'm putting on the left-hand side, and I'm going to add something else to it. Okay, so this line of code does exactly the same thing as this line of code. Want me to prove it to you? I will compile. And test. Does the exact same thing. Okay? So it takes a variable and adds something to itself. All right. And as I mentioned, you can use any of the operators and do the same thing. So here, if we had minus equals, then it would take number of scoops and it would subtract whatever is on the right-hand side, which is 1. And so then it would be the same as num scoops equals num scoops minus 1. That would be the same thing. All right, I'm just going to leave my original add and assign operator. Okay, and then we have what we call the prefix or postfix increment operators. These last two bullet points, they do almost the exact same thing. The textbook explains the very minor difference between writing it this way or writing it this way, putting the plus plus before the variable name or putting the plus plus after the variable name. In 95% of the cases, these will do the exact same thing. So for now, just consider them equal. I think maybe in a later video, I might go into the differences between them. For now, consider the prefix and the postfix to be to essentially do the same thing. But what happens is if you have the name of a variable and you put 2 plus signs, either before it or after it, that adds 1 to that variable. Okay? Or if you do 2 minus signs right before or right after the variable name, that subtracts 1 from that value. Okay? So back in our code. Okay, here with the add and assign, I could have put anything I wanted here on the right side. I could have put 1, I could put 2, and that would be the same as adding 2 to it. Or I could put a variable name, tax. I mean, that wouldn't really make sense in this case, why you would add the tax to the number of scoops. But my point is you can put any number or any variable that holds a number on the right side of this add and assign operator. Okay, with these prefix and postfix incrementers, it always just adds 1. You can't like add 2 or add 10 or add any other number with this. This is just a shortcut for adding 1 to a number. Okay, so if we do num scoops plus plus, this is a shortcut. So this is an entire statement of itself. I'm going to put a semicolon at the end. This does the exact same thing as this, which also does the exact same thing as this. So you're taking a variable and you're adding 1 to it. Okay, so if when C# is processing the code, num scoops doesn't exist. Oh, now num scoops exists with a value of 3. Num scoops is 3, num scoops is 3, num scoops is 3. Oh, now num scoops holds the value of 4. So when we continue on in our code, when we use that variable at this point in time, num scoops has a value of 4. If you want to pause, catch up, I'm going to save and test this code. Yep, number of scoops is 4. All right, that's it for the numeric data types. I will save and post the ice cream file as ice cream 2, and then I will continue on with the ice cream example in the next video.